In question 10, a student investigated the reaction between dilute hydrochloric acid and two different solutions are there of sodium hydroxide O and P. Burette was filled with hydrochloric acid. So from the burette, student add hydrochloric acid. So HCl is there in a burette. And he poured 20 cm cube of solution O in a conical flask. So there is solution O, but how much it is? 20 cm cube. And then thymol pathylene indicator was added in a conical flask. A dilute hydrochloric was added from a burette, and he swelled the mixture until the solution shows a color change. The final burette reading. So what is the initial and the final burette reading? You can use screen annotation. So initial is 4.1 and final is 29.6. So how much is the difference? What is the difference in the volume? 25.5. Okay. And then, so how much hydrochloric acid is needed for the first reaction? We need 25.5 cm³ for the first one. Then he did the experiment. He again filled with a hydrochloric acid, and then a conical flask is there. It is filled with solution L. Solution P was there. That is also because O and P are the solution of sodium hydroxide, but they will have a different concentration. So they required a different volume for a complete reaction. So experiment 2 was done with repeated using a burette reading. State the final burette and the initial burette and the difference. So 24.0 and the final is 29.1. And what is the difference? So 5.1. So same HCl is there, 5.1 cm³. So can you identify which solution P or because same HCl was used in both experiments, but for P only we need like 20 cm³ of P required only 5.1 cm³, and where 20 cm³ of O required 25.5 cm³ of HCl. So which solution is more concentrated, P or O?
Solution P because it took less volume or needed less.
Which is more concentrated, P or O?
P.
No, the correct answer is O. Because the same HCl, I'm not talking about the HCl, which solution, because HCl is same. For a complete reaction, I just use 5.1 cm³ for a complete reaction with P. But here for a complete reaction, I use 25.5 cm³ of HCl. So I need more moles here. Like there are more moles present in O as compared to moles present in P. That's why HCl, small quantity of HCl completely reacted. Here, large quantity of HCl will react and neutralize this. So solution O is more concentrated. Here, you have two solutions. You have two solutions. One is solution P, which was 20 cm³ NaOH, okay? And you have solution O. You did another experiment and you have solution O. That is also like 20 cm³ is there, 20 cm³ of O. This is experiment 1. This was done first and this one was done second. When student add HCl from the burette, how much HCl was needed for the how much HCl was needed?
25.5.
So 25.5 cm³ for a complete reaction. But here this solution, they use the same HCl, but they only need 5.1 cm³ for a complete reaction. So question is, which solution, O or P, is having more particles inside or more moles inside? So which solution is more moles or more concentrated or more particle? That is solution O. Why O? Because I need more volume of acid for a complete reaction. Here, I need less amount of HCl for a complete reaction. So solution O of NaOH is more concentrated as compared to solution P, which is having few particles or less concentrated. Is it clear, this one?
Clear this one? Yes, sir, clear.
The next one, what type of a chemical reaction occur when hydrochloric acid react with sodium hydroxide? So when acid react with a base, what we call this type of reaction? So we call neutralization. Then which solution of sodium hydroxide, O or P? Which solution of sodium hydroxide, O or P, is more concentrated, and explain your answer. So which solution is having a high concentration? So we'll mention O. And why O is having a high concentration? Because it required a greater volume of HCl for a complete reaction. And how many times more concentrated? So how you'll identify how many times more concentrated? Because how much HCl was needed? The HCl needed was 25.5 cm cube to react with O. And how much HCl needed for reacting with P? That was only 5.1. So what is the ratio of the volume? It is 5:1. So it is like 5 times more concentrated than, like O is 5 times more concentrated than P, because O need 5 times greater volume for a reaction as compared to that of P. If experiment 2 were repeated, using 10 cm cube of solution P, what will be the volume of hydrochloric acid? Look, in the first experiment, we took 20 cm cube of P, like the when P was there, we took 20 cm cube of P, and how much HCl was needed for a complete reaction? It was 5.1 cm cube. Now they are saying if we do or carry out the same reaction, but if we carry out the same reaction with different amounts, like example, we use 10 cm cube of P, so how much HCl is needed? So if I half the volume, like,
2.55.
so it will be
55.
2.55 cm cube. Because how I identify, you can clearly see, like if I was having 20 cm cube, I need 5.1. But if I have 10 cm cube, so I need half of it. Half of 5.1 is 2.55. So what volume of a hydrochloric acid is needed? You will mention 2.55 cm cube. And reason is that because the volume of P become half. Like originally it was 20, but now it is 10. You can also use the ratio, you will get the same answer. Like how you get the same answer? If you compare the ratio between P and HCl, it was 20 required 5.1. So 10 will required X. Cross multiply, you will get 2.25, 2.55. It's the same answer. Then in part F, what will be the effect on the result if we warm? So in a titration, there is no effect. Why there is no effect? Because we are using a same amounts, same concentration, same amounts of solutions are used, so no effect on temperature does not affect the volume required for a titration. Would be what would be more accurate method of measuring a volume of a sodium hydroxide? If you want to measure sodium hydroxide, so it was 20 cm cube, so we cannot mention here pipette, we have
Burette.
to mention a burette. How you check the reliability of the result? How you will be sure that your results are
Repeat the
reliable?
experiment.
You are repeating the experiment.
And comparing.
Repeat the experiment, compare the result. Then sodium hydroxide react with calcium chloride to form a precipitate. Use this information suggests a different method to find out which solution of sodium hydroxide is more concentrated. So how you can work out which solution of sodium hydroxide is more concentrated? So what you will do, you will take equal volume of two solutions. You will take equal volume of solution P and solution O. And then what you will add calcium chloride, like solution of a calcium chloride or aqueous calcium chloride. When you add calcium chloride, calcium react with sodium hydroxide. As a result, it will produce precipitate, white precipitate. So the one which is having a higher concentration will form greater amount of the precipitate. You will filter, wash, and then wait. The one which gives a greater mass of a precipitate or greater amount of a precipitate, that is having a high concentration. Like I will take two solutions, I add to salt solution calcium chloride, aqueous calcium chloride, and I will find how much like excess of a calcium chloride until the precipitate does not form, and then we'll filter and dry and reweigh to know which one is giving the higher mass will have a high concentration.